For the kind introduction, I would like also to thank the organizer for the invitation, and also I would like to say hi from my side to all of you. Today, we would like to present one of the projects we are working on that incorporates artificial intelligence trying to interpret the data regarding how is the quality of the recycled plastics, just trying to look for the most proper application. Yeah. So before, I would like just to comment about our company for those who do not know us yet. So we started as Cadel in 2012 because we are a technological company based in Alicante, Spain. And one of the things we realized it was the need to remove the ink in order to upgrade the quality of the recycling plastics. And this was the reason why we developed the inking technology that is a water-based process that works in a closed loop. And it was patented in 2014. And the technology is already corroborated by the sales of the industrial plants we have been sold over the world. So we have around 7 industrial plants already established, and the last one is the one that my colleagues are building up in UK. The technology was bought by Arema via its subsidiary Keycycle in 2021. And since then, we are still giving them the engineer support for the new plants we are building. Since this is a portfolio of products that are being able to be the ink by our formulation, as you can see, even car bumpers are able to be the ink. And this is the industrial line we have, or the pilot line, sorry, we have in our facilities in order to validate the technology for those clients that want to test their material. And since we sold the technology to Keycycle, the subsidiary of Arema, we changed the name to Cadel Recycling Lab, always continuing in the same direction, just trying to develop new recycling technologies and trying to get information about the quality of the recycling plastics. And one of the products we would like to present today is a quantum software, because we saw the need in the industry trying to get interpretation of all the data you have from the recycling material. So before I get into detail, I would like just to start just by inform you why we get to the idea and which is the need we saw in the market in order to work in this project. And that's the reason why I decided to put different scenarios that they are pretty routine for you. So just to buy a house or trying to decide which is the shortest group, and also if you want to have a run. There are normal activities, but all of them have something in common. And before you make the decision, you need data, and then you need to interpret them. Then with all the data, you can make the decision if it's the most suitable or warm day to have a run, or which is the shorter route just to avoid traffic jam, for example. So we try just to use this approach because we believe that also to have data is important to collect and also to interpret it. Because all of these, you need to do it in order to have the best decision. So just having this in mind, we thought, OK, what about plastic? So we can incorporate this idea in the recycling industry, just trying to differentiate or to classify which kind of material has the quality you need for your process or for your product. So with this idea, we just trying to put different scenarios that we realize that the recycling industry has or the need the industry has. And one of the questions is, which is the value I have for my recycling material? Or how I can classify depending on the quality. For sure, it's not new for all of you that the new regulations are coming. How I can comply with this? So with all of this in mind, the point is that you need a lot of data, or you have a lot of data in your table, but you need to interpret this. So until now, we have not seen in the market any tool or digital tool that can help you to make this interpretation. And well, this is a bit just a recap about how the new regulation it's facing, and also the need to introduce recycling content in your packaging. So we thought it was a good idea to work in this product. And we start designing quantum tools, just trying to have different pillars. So one of them, it was just to assess the quality of the material in terms of contamination. So to check how is the contamination of the recycling plastics, and if it's in allowance or not of the regulation you want to compare with, like food contact regulation or the proper standard that the company has. Also, give information about the recycling content that you have in your packaging, because as far as we know, there are not really standard protocols to determine the recycling content, and also probably to avoid greenwashing techniques, this can be a useful tool. And as I was commenting, because of the fluctuation in the quality of the recycled material, we thought that it was a good approach, a good product to incorporate into the market. So here is just a few business cases just to show you the power fields of the tool. We have been working with a converter company that is making film for different applications, such as hygiene, cosmetic, and also they have some food-grade products. And we try to help them just because, as I was commenting before, the fluctuation of the quality and also the availability of the stock they have. So they need to buy material from different suppliers. So then they also needed a proper tool or approach trying to differentiate the quality of the different providers that has the quality they need for the process. So they had problems about the interpretation also of the contamination of the plastics, because they were commenting to us that they were getting a contamination report from a laboratory, but there was no interpretation behind about which these parameters means and which kind of decision they needed to take. So with all of these, we're trying to make an approach for the company, because if you want to follow completely what the regulation says, you need to analyze everything. So you need to analyze and to follow the 10/2011 if you are working in food contact materials, but you also need to check those NIAs, which are substances that are not present in the packaging, not intentionally added, but are present for some way. So that was the reason why we designed a protocol for the company. So we are analyzing the different sorts of recycling plastics they have. So we select those group of contaminants that are target for us. And then we just, with this, we introduce the data in our software to get the report and information about how the quality is. So here is how the report will look like. So you have information about the material that you want to analyze, the packaging you want to build up, and it's giving information about the recycling content you can introduce in your packaging. So for me, one of the things I would like to highlight the most is this table that I know probably it's not easy to see, but I guess you will have the slides later on so you can check better. But the point here is giving all this interpretation that you are missing. So for example, in green, there are the substances that are passing the 10/2011 regulation. The red is the one that is not compliant, so the concentration is above the limit. But also it's important here that is detecting the NIAs. So those substances that are not in the regulation and you need to check. And the one that has a light color means that it's an NIAS that is not CMR. So in principle, if you are in a concentration below the limit, you are OK. But the problem would be with the ones that it's a darker yellow color, which means that are CMR, cancerogenic, mutagenic, reprotoxic substances that should not be present in the packaging if you want to use it for food application. So with this information, you have a lot of interpretation that is helping you to make the decision. Here, there are just a few samples from the company. So with the different materials we were analyzing and the classification we had. So in the case of the PCR D, so it was in the area of premium recycling plastic. And in the other case, for example, for B, it was not reaching the quality the company needed. So it was just, they just removed this material and they avoided to put it into the line. And the last thing, very brief, I wanted to comment that to get the report I was presenting before, in some point you will need to create the data. But this, for the recycling industry, sometimes take a lot of time. And for the production or to maintain the speed of the production, sometimes it's not possible to wait until you get the analysis of the recycling plastic to know, OK, I can use it or not. So that was the reason why we decided also to incorporate artificial intelligence via image recognition, trying to sort the quality of the recycling plastics. So I will present just a preliminary results, but we are looking for partners that want to collaborate with us in this topic, and that's the reason why I wanted just to briefly comment the state that we are so far. So the way we work is very easy. So we take the picture of the recycling plastic material, and then we make the convolution of the image, and then we feed it into the system. So as we were hearing in the first presentation of today, it's important for the artificial intelligence to feed with a lot of data to train the system, so then it's able to learn by itself and then give the information that is useful for you. So the first thing I would like to show you, it's about the determination of the recycling content. So this is examples for LDP packaging that we are just making we make the training with different amounts of recycling content, and then we are in the validation step, in which we are putting samples that are not fitting in the training step, just to see the validation and how we are in the accuracy, and we are so far reaching 72% of accuracy. That for sure is not perfect, but we believe just incorporating new data, we are enhancing this value. And this is just how it works, the software we have so far. So we will launch the new update by the beginning of September. But as you can see here, so there are the different stages of the software. But I just wanted to go directly into the image recognition, where you can just upload the picture you make, and then automatically it's giving information about the recycling content you have in the sample. The last thing, it's also that we didn't stop just to determine the recycling content. We also wanted to try to see the classification of the recycling material via image recognition. So we have started this project for the easiest one. So we try to just classify virgin material with and without additives. So we know that the virgin LDP with additive has normally around 0.03% of arucamide, for example. So we decide, OK, we are able to differentiate this or not. And here are the first results. And as you can see here, we make different pictures of LDP with and without additives. And we are able to see how the classification or the clusterization of the material is perfectly differentiated, which means that at least we can reach those levels in which the substance is present in not very high amount. So for us, this is a promising result, and now we try to train the system with new other substances like bisphenols, phthalates, and so on. So this is just a takeaway about how the tool works. Yeah, I would like to thank you for the invitation and also for your assistance. So thank you.
Okay. Yep, good. Thank you for the presentation. And the question is about your de-inking process. The second part was also very interesting. With de-inking, can you give a number to the complete removal of ink? For example, is it 95% or 98% or 100% removal of ink? Or does it depend on the ink and the film and so on?
Now it's me, right? Yeah. Now I work. Thank you. So regarding the de-inking technology, it's true that it's better to ask the question to Keycycle or EREMA that now holds the rights of the de-inking technology. But I would like to ask also your question. And the average normally is around 95, 99% of removal from surface printed plastic and also coating. But it's true that sometimes depends on the material. So the way that normally we work is we make a test in a lab test to see or to adapt the conditions, and then we make validation in the line we have in our facilities. But for surface printed plastic like LDP for diapers, for example, works almost 99% removal. So you get very wide recycling material. But for more information, I can give you the information and ask them. Yeah.
Thanks so much for that. Any other questions? I had one which I think you kind of touched upon anyway, right at the end, but I was going to ask about whether this technology can be used to detect legacy additives that have been banned, and I think you mentioned bisphenol A and phthalates, and I guess going forward PFAS could also be an issue.
Yeah, so the point is, you mean for the image recognition, right?
Yes, yeah.
Yeah, so now this is we wanted to have kind of validation if the process can work. So that's the reason why we start with virgin plastic to see, okay, we are able to differentiate, and also which is the concentration we are able to determine, because for sure, probably we cannot go to very low levels. So we want to have a range about which is the detection limit we have and which is the concentration we can analyze. And the idea is to incorporate bisphenols, phthalates. PFAS is also one of the, I guess, the targets now the company has. But it's true, we have not tried if we are able to recognize by the image. But because we are combining a technique in which we are making the image and also chromatography and different techniques, just trying to train the artificial intelligence side, we guess we believe this can work. So yeah, for sure, it's one of the tasks we have.
It'd be really interesting.
And that's the reason why also we are asking for partners and collaborators, because the collaboration of the different sectors of the company can be very useful to upgrade the tool.